welcome back to our Algebra 1 series. Today we're starting a new section, Section 3, and today we will be continuing our discussion on exponents. As a bit of review, exponents are used when you multiply the same thing over and over again. For example, x times x times x times x can be written as x to the fourth power. We write a 4 because x has been multiplied by itself 4 times. For this example, x times x times x times y is equal to x cubed y squared. There's a small 3 because there's 3 x's, and a small 2 because there's 2 y's. Feel free to go back to section 1.3. There's a whole video on exponential notation. Today we'll be covering multiplying powers. So for example, 8 cubed times 8 squared means 8 times 8 times 8 times 8 times 8. Or just 5 eighths in a row, or 8 to the 5th power. If you look at the exponents that we started with, 2 and 3, they're added together to create the exponent that we ended with. So for any rational number a, for all whole numbers m and n, a to the m times a to the n equals a to the m plus n. When you have a common base and different exponents, you can just add them when you multiply. We're jumping right over the whiteboard for some fun examples. Alrighty, exponents and exponents. Let's do x times x squared times x to the 5th. So for this example, I'm going to write them all out so we can see what we're talking about. Here's the first x times x times x. There's 2 x's because of the 2 times x times x times x times x times x. 5 x's because of the 5 here. So we've got a bunch of stuff all multiplied together. Doesn't matter what order we do it in. So we've got x times 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 x. And that's 8. X to the 8th. So we could have just added the exponents. But what you have to remember is that there's basically a 1 up here. So 1 plus 2 plus 5 is 8. Let's look at something a little bit more interesting. A cubed times b squared, that whole thing multiplied by a cubed b to the 5th. Okay, so again, we've got a bunch of stuff that's all being multiplied together, but we could rearrange it like this if we wanted to. But we know that with a common base, we can just add the exponents. We've got an a to the 3rd power and an a to the 3rd power. So we know we'll end up with a to the 6th power. We have a b squared and a b to the 5th. 2 plus 5 is 7. So this simplifies to a to the 6th times b to the 7th. Next, we'll cover dividing powers. So for example, x to the 5th over x squared, we could write it out with all the x's on the top and all the x's on the bottom. We know that 2 x's would cancel from the top to the bottom. We would be left with just x times x times x, or x to the 3rd power. Again, if you look at the exponents we started with, 5 and 2, this time we subtract them to get to the 3rd power. X to the 5 minus 2 power equals x cubed, which is what we got the first time around. So for any rational number a, for all whole numbers m and m, a to the m over a to the n equals a to the m minus n. We subtract powers when we divide them. I'd like to look at this problem where we just flipped the fraction we started with. Now we have x squared over x to the 5th power. X times x over x times x times x times x. Once we simplify, we have 1 over x times x times x, or 1 over x cubed. Again, looking at the exponents we started with. It should be x to the 2 minus 5. Well, that's x to a negative 3, and that looks kind of weird, but that is allowed, and the property that we discussed still holds true. When you have a negative exponent like this negative 3, it really means 1 over x to that same positive number. So it's almost an inverse. Typically, exponents shouldn't be written as negative numbers. They should be written as a denominator in a fraction. All right, we're heading right back to the whiteboard for some more fun. Alrighty, we're going to divide some exponents. X to the 6th over x squared. So we have x to some power, x to another power. We know the answer is going to be x to the 6 minus 2 power, because we're dividing. So x to the 6 minus 2 is equal to x to the 4th. And we could have written it out and put 6 x's on the top and 2 x's on the bottom and canceled out 2 of them and had x to the 4th power. Let's get a little more interesting here. P to the 5th power times q to the 7th all over p squared times q to the 5th. Now this would be a lot of p's and q's to write out, but let's just focus on one variable at a time. It's going to be p to the 5 minus 2 power. I will write it out. 5 minus 2 times q to the 7 minus 5, because we're dividing. 7 minus 5. So I'll just rewrite this. 5 minus 2 is 3. So p to the 3rd power times q, 7 minus 5, is 2. P cubed, q squared. That's hard to say. And that's it for today. If you'd like, stick around for a bunch of examples. Alrighty, let's multiply some exponents. X to the 4th times x to the 3rd. Again, I could write it all out, put 4 x's and then 3 more x's, but all we really need to do is add the exponents. So this one is x to the 7th. And that's it. That's as simplified as you can get it. Let's try y cubed times y to the 4th times y times y. I think my marker's starting to die here. So we've got y to the 3rd, y to the 4th, and we're gonna cheat a little bit and just put a 1 up here. 1 to the 1st power, 1 to the 1st power. That way we can add all the exponents and end up with the right answer. Make sure we don't miss these guys over here. So equals 3 plus 4 plus 1 plus 1 y to the 9th power. 3 plus 4 plus 1 plus 1. Yep, that's 9. Let's do 1 up here. A cubed b to the 6th times a to the 5th times b. Again, don't let the parentheses necessarily confuse you. We're multiplying a bunch of stuff together, and it doesn't matter what order we do it in. So the a's can be multiplied together and the b's can be multiplied together. So let's do just that. A cubed times a to the 5th is a to the 3 plus 5. So it's a to the 8th power, b to the 6th, and b to the which is really 1. Make sure you remember that. So b times 6 times in a row times another b is b to the 7th. Going forward, I probably won't be writing the 1s next to exponents. You just need to know to keep that in mind. And that's it. That's as simplified as we can get it. We'll do one more before we jump over to division. That's 2x y squared all of this times 2x squared y squared. So now we've got some numbers involved, but we can treat that the same way. Let's deal with the numbers, then we'll deal with the x's, then we'll deal with the y's. Because we're multiplying everything together, we're allowed to do that. So let's start with 2 times 2. Okay, well, that's 4. X and x squared. So here's 1x and here's 2x's being multiplied together. So that's really x cubed. Y squared and y squared. We're going to add the exponents. 2 plus 2 is 4. So the answer is 4x cubed y to the fourth. Okay, let's clean this off and work on some division. Alright, let's do something with some numbers. 7 to the 5th over 7 squared. So 7 to the 5th is some terrible number. Let's not bother figuring that out. But since we're dividing the same base with different exponents, we can subtract the exponents. This is equal to 7 to the 5 minus 2 power, or 7 cubed, which is 49 times 7, which is some number we don't need to worry about, but that's good enough for now. Let's take a look at some variables, like y to the 9th over y to the 5th. Again, it's the same base with different exponents, so we can just subtract the exponents. This is equal to y to the power, that is 9 minus 5, or y to the 4th. And that's it. Let's make it slightly more difficult, but not too terrible, right? Let's put some numbers and variables together. 4 cubed times x cubed over 4 squared times x. So we can treat this the same way. Let's just do the 4's, then we can do the x's. 4 cubed over 4 squared is equal to 4 to the first power, 3 minus 2 is 1, times x cubed divided by x, so 3, and here's an imaginary 1 I was not going to do again, but 3 minus 1 is x squared, or we could just write it as 4x squared. Let's just do one more here. A cubed times b to the 4th over ab. And again, this a is really a to the 1. This is really b to the 1. So we're just going to look at the a first. 3 minus 1 is 2, just a squared. And 4 minus 1 is 3, so this is b cubed. And if you think about it, you had 4 b's on top and 1 on the bottom. One set of b's would cancel out and you'd be left with 3 b's. And there you go. And that's it for today. We'll see you next time.